Hi everyone, welcome to my course Practical Data Analysis with R Programming. I'm going to be your instructor for this course, Adejumo Ridwan Suleiman. So you know that R is a programming language. If you want to use the R programming language for data analysis, then this particular course is for you. If you want to analyze your data and explore your data, stuffs you do in tools like Excel, Power BI, or in BI tools in general, then this particular course is for you. So I'm going to be your instructor in this course, Adejumo Ridwan Suleiman. I'm an experienced data scientist and also an R developer and also a statistician. I've been using the R programming language for the past years. So I'm going to be teaching you how we can now use this particular R programming language using some special packages to perform data analysis, on your data sets, explore your data sets, manipulate it, and also I can gain reasonable insights from these data sets. So what are you going to learn in this course? First of all, we're going to be talking about data visualization. How can you visualize your data? So how can you present your data in a pictorial format? You know the popular saying which says a picture speaks 1,000 words. So that brings the importance of data visualization in data analysis. I'm going to be showing you how you can explore your data using data visualization, how you can gain reasonable insights and also interpret your data using data visualization. I'll also be explaining to you how you can manipulate your data, filter your data, create another data set from your data, how you can filter this data, create another data set from this particular data, explore some insights from this data. Also, I'll be taking you on data tidying, how you can tidy your data. Most of the times in the real world, these data sets come in a dirty format. So how can you tidy this data using R programming? And also, we're going to take on a case study which I'm going to show you a full workflow of a data analysis process. The tools we're going to be using are called the tidyverse packages. So with the advent of data science, and we all know that R is a statistical programming language, so this is where the tidyverse packages come. So these tidyverse packages was designed to aid data science. So which means that with this, most of the tools that comes with the default base R aren't able to perform data analysis workflow processes easily. This is where the tidyverse packages comes. So I'm going to be talking about the ggplot2 package, which is used for data visualization, the dplyr, which is used for data manipulation, the tidyr, which is also used for data tidying and cleaning, and the readr and readx package, which is used for importing structured data into the R programming language. So these are the tools that we're going to be using in this course to explain to you how a data analysis workflow in R looks like. So what are the problems we are going to be solving in this course? We are going to be solving the diamonds problem. This is a data set containing the price of various diamonds and also their characteristics. We are going to explore this data set to also see how these characteristics affect diamond price and how can we know that okay, a diamond is good or a diamond is bad. Then we'll also go to the New York flight data set to see how we can explore flight delay and also analyze reasons for flight delay in various flights in the data set of New York flight 2013. We'll also talk on the AdventureWorks data set, which is a data set for a multinational company, a fictional multinational company, which performs online transactions. So we're going to be analyzing this data to see how sales are in these particular organizations, what can be done to improve sales, the kind of customers that are buying a particular item. So these are the problems that we're going to be covering in this particular course. So please, I want you to sit down. So in this course, there are going to be exercises at the end of some sections. So please, I want you to try and answer these exercises with also resources that will be available in some lectures. So you should try and download those resources, and also the codes are going to be available at the end of each particular section. Some of you are familiar with the R file. So this is the file where you write your R code or your R scripts, which you can save and share with others. But throughout this course, I'm not going to be using this R file. So for those of you that are not familiar with R Markdown, I'm going to introduce you to R Markdown. So R Markdown is just like Jupyter Notebook in Python. So this allows you to run your code on a particular code chunk, and when you run it, you can see your output just below that particular code. So if you want to create an R Markdown file, you go to New File. You're going to see it here, R Markdown. So here you can name it, you can give the name of your document, which in this situation I'm just going to give. So I'm going to give the name of the document, Practical Data Analysis. You can also give your name, the name of the author, the person writing the document, and you can also choose in which format do you want your document output to be, because with the R Markdown, you can render it either as an HTML, a PDF, or a Word document. So these are the advantages of R Markdown. So it is this R Markdown I'm going to be using throughout this course to explain to you how you can perform a data analysis workflow, because most of the time, after performing your analysis, you want to share your codes and also your output. Another advantage of the R Markdown is also allows you to write in text, just like writing in a Word document. As you can see, this is the code chunk where you can run your code. This is where you can write your text. So these that are starting with hash, these lines where you see a sentence starting with hash, these are the headings. You can have a single hash heading like R, and you can have a double hash heading like R Markdown. So if I am to render this, let me knit this to HTML. You can see the output of this file. So I will need to first save it. Let me save it as practical. So can you see now the R Markdown document has been rendered to me in an HTML format. I can also render it to PDF. I can render it to Word document, depending on the kind of file format you are interested in. So it is this R Markdown I'm going to be using throughout this course to explain some of these concepts and topics to you. So anytime I run a code in the code chunk, I'm going to expect my output. So let me clear this and just show an example of the popular iris dataset. So unlike the R file, when I run it, it is going to pop up on my console. But in this situation, I'm just going to see my table just below my code. So for every code that is going to produce an output, you just create an R Markdown chunk. So for every code that is going to give you an output, you are going to create a R chunk. And this R chunk can be created using Ctrl, Alt, and I. So when you type on your keyboard Ctrl, Alt, and I, you can create this R chunk. So Ctrl, Alt, and I is the shortcut for creating this R chunk. Another thing that I'm going to be using throughout this course, which might look new to some of you, is the pipe operator. So what is the pipe operator in R? Well, the pipe operator allows you to pass a variable or an argument to a function. A package called the migratory package was also created, which consists of the pipe operators. So this is the package. For those of you that don't have it, you can install it using the install.packages function. And if you want to load the migratory package, you use the library migratory and you load it. This stress has already been cut for us. Some of the packages we are going to be using, like the dplyr, the tidyr, they have this package pre-installed with them. So you don't need to load this package for you to use the pipe operator. So how does this pipe operator works? Let me give a typical example of the head iris. This function allows us to get the first 6 rows of our data set using the head function, where we can also signify the number of rows that we're interested in. If we're interested in 10 rows, I can use head iris 10, and the first 10 rows is going to appear. How does the migratory package works? So anytime you pass an argument or a variable to a particular function, then this is going to be the same thing, just like writing the function with that variable inside. So look at this function where we wrote head iris, 10, the first 10 rows of the iris data set. I can also write it like this by first of all passing the data set, then the function head, then also with my argument, which is the number of rows, 10. So you can see that I also get the same number of rows as I got when I wrote it before, like this. So I'm going to be using this pipe operator throughout this course. So just know that anytime I write maybe a data set or maybe a function to another function, it's also the same thing as using that particular function. Why this pipe operator was created was to make it easy, because sometimes you can nest a function inside a function. Like for example, now let me show you head, then I can say mean, iris, and I can say separate length. And you see that I've already nested a function inside a function. So sometimes this might look confusing. So instead of writing this nested function like this, I can just make it easier for me and just say iris, I can say separate length, and I'll pass it to the mean function, and I can now pass it also to head, which I can still get the same thing. So this is I'm just trying to explain to you how it is easier for you to use the pipe operator. So it's passed a much more inner function to another inner function, then the last is going to be the outer function. This is what the pipe operator does. But throughout this course, you are not going to be seeing me using this pipe operator. You are going to be seeing me use R's native pipe operator. For those of you that have the updated version of R, when you go to tools, you go to global options, you click on code, and you can see this checkbox here that is unchecked, use native pipe operator. So this is R's native pipe operator, which means you don't need to be loading any package to use this. You just have to tick this box as I have ticked it now and click on OK. So the same thing that I wrote here, I can write it iris, separate length, I can see the pipe operator, then mean, then head. So when I run it, I can just get my digit. So this is just an example. With time, as I'm going through the lectures, you are going to understand the pipe operator better. So now you're going to be wondering, this is very tedious to be writing all the time, percentage greater than, percentage, or I should be writing this symbol and also greater than. So there's actually a shortcut, and that shortcut is Ctrl+Shift+M. So once you press Ctrl+Shift+M on your keyboard, you are going to have the pipe operator. So I just want you to know that this pipe operator just allows you to pass variables or arguments to a function. So it is better when you have functions that are nested in each other, you use the pipe operator to pass it from the innermost function to the outermost function. So if you have 5 functions inside each other, for example, now I can have head, mean, I can have sum, and I can have the particular data. I'm just giving an example. So this is just an example. So instead of writing it like this looks confusing to anyone that's trying to read this code. I can just say iris. I'll start from the innermost, which is the data set, and I'll pass it to the sum. Then I'll also pass it to the mean. Then I'll pass it to the head function. So as easy as it is, you can see that now it is much more easier to read. You know that, okay, this is my data set. I find the sum first, then the mean, then the head. So that is all about the pipe operator. I'm going to be using it throughout this course. So the more you see it in other lectures, the more you're going to understand how it also operates.